Let's look at hierarchical agglomerative clustering, commonly known as HAC. So we are now looking at single linkage. We are having 6 points. So we just plot the points on a graph like this. Point number 1 is at x value 0.4 and y value 0.53. So x value 0.4 and y value 0.53. We have plotted the point number 1. Similarly, we have gone ahead and plotted all the points. Next, we have to go ahead and make the distance matrix, wherein what is the distance between point number 1 and point number 1? It is 0. What is the distance between point number 2 and point number 1? We have to write over here. Similarly, we have to just fill in the complete cells out here. So these are the various points that we are considering, and this is the distance matrix. Now, how did we get the distance between point 2 and point 1? Which is 0.23. So we have to see the graph that we had created. Now over here, the coordinates of point number 1 is 0.4, 0.53, and coordinates of 2 are this. So now we have to find out the Euclidean distance between 0.2 and 0.1. So we have to find the measure of this particular line. That could be found out like this, and the measure of this particular line can be found out like this. So the measure of the hypotenuse can be given as this, and the result is 0.23. So now distance between 0.2 and 0.1 is 0.23. Now we have to go ahead and thus similarly find the distance between each and every point, point number 3 and 2, all of the points. So once we have found out the distance matrix for all the points, then we have to go ahead and see which point is nearest to each other. So we find that point 3 and 6 have the least distance. So what we'll do is we'll combine 3 and 6 and put them into one cluster. So we have made this dendrogram and we've combined 3 and 6. Now we have to update this distance matrix, wherein 3 and 6 are taken as 1. The data in all the cells would come as it is. Only for 3 and 6 we have to see which is the minimum value, and that minimum value will come over here because we are looking at single linkage. So for that we have to see the minimum distance between 0.1, 0.2, 4 and 5. Minimum, the distance between 3 and 1, distance between 6 and 1, whichever is minimum, we'll be taking that. So distance between 1 and 3 is 0.22, distance between 1 and 6 is 0.23, so this is minimum, so we'll be considering 0.22. Similarly, we'll go ahead and find the distance between 3 and 2 and 6 and 2. 3 and 2 is this, 6 and 2 is this, so this is the minimum value, so we will take it as 0.15. Similarly, we'll go ahead and calculate the other values for the other points and replace all these values in the cells like this. Okay, now we'll see the distance matrix and just find out which is the least number in the matrix out here. We find that the distance between 0.5 and 2 is the least. So what we'll do is we'll combine 5 and 2 together and make it into one cluster, and the dendrogram looks like this. Now the distance matrix would be combining 2 and 5 together. So 2 and 5 is combined together, 3 and 6 were already combined in the first iteration, and the data is coming as it is for these points, and the values in the peach colored boxes would come as you know, minimum distance between the points 2 and 1, 5 and 1. So 2 and 1, the distance is 0.23. 5 and 1, the distance is 0.34. So we'll take the least one. So the value would be 0.23. Similarly, we'll go ahead and find the distance between 2 and 4, 5 and 4. Whichever is the least would come as 0.20. Next, we have to go and see what is the minimum distance between 0.36 and 2. 3, 6 and 2, the distance is 0.15, and 3, 6 and 5. 3, 6 and 5, the value is 0.28. So we would be taking the value as 0.15. Now we are going to fill up our distance matrix. Okay, now we'll consider the latest distance matrix that was with us. Now the distance between point the cluster 3 6 and 2 5 is 0.15, which is the least. We can consider this, or we can even consider this and move ahead. So how would the clusters look like? The latest cluster would look like this, and the dendrogram would look like, we have combined the two clusters into one now. Now we'll make the new distance matrix wherein we have combined 2 5 and 3 6 together. Now the value of distance between 1 and 4 will come as it is. Now we have to calculate the distance between 2 5 and 1 and 3 6 and 1. So the distance between 2 5 and 1 is 0.23 and 3 6 and 1 is 0.22. So the value of the minimum between the two would come as 0.22. Next is the value between 2 and 5 and 4. 2 and 5 and 4 is 0.20, and 3 6 and 4. 3 6 and 4 is 0.15. So 0.15 is less, so we have taken that. And now we'll fill up the distance matrix. So let's look at the latest distance matrix. We are going to look at the least number that is existing in the matrix, and that is 0.15. So now we have to combine this cluster with 4. So the structure, the cluster that we had created till now was this. Now we also have to combine 4 into this cluster. So the dendrogram would be updated. 4 would have to be attached to the cluster, and the new cluster looks like this. Now if you make the new distance matrix, we'll have to combine 4 with the rest. Now to get the value for this, how do we go about and see that is the distance between this particular point and 1 is 0.22, and distance between 4 and 1 is 0.37, and the least value is 0.22. Thus we have taken 0.22 and we have replaced it over here. So let's see the latest status of our clusters. These are the clusters that have already been created. Now only point number 1 is left out from the cluster. Let's look at the distance matrix. In the distance matrix, we find that there is only one point, that is 0.22, which is least. So now we have to just combine point number 1 with the rest of the cluster. So the last dendrogram looks like this. So point number 1 is also attached to the dendrogram. So this is the final dendrogram that we get, and the clustering, the last cluster would also include number 1. This is how we find out clustering through single linkage in HAC.